Welcome to this Algebra 2 session on systems of linear inequalities. So first, we're looking at determining whether ordered pairs are solutions to systems of linear inequalities in two variables, and drawing graphs of systems of linear inequalities in two variables. So the first one we're going to look at has to do with fractions, because I know how much we love fractions. Determine whether the ordered pair is a solution. The ordered pair negative 2/3 and 3/4, we're deciding if it's a solution to this system. So that means that both numbers, we have to substitute into both inequalities, and we have to get a true statement in each. So we're looking at y greater than or equal to x minus 5/6 and y greater than 3/5 x. So we're going to focus on taking the first ordered pair. We're going to take the ordered pair and put it into the first equation. So we will have the negative 2/3 will be filled in for x, and the 3/4 will be filled in for y. So 3/4 again in for y, and negative 2/3 we're filling in for x. And now we'll calculate if this statement is true or false. So the easiest, I know we don't like to deal with fractions, so the quickest way to eliminate a fraction is by multiplying the entire inequality by a multiple of 4, 3, and 6. Or you can get a common denominator. You will get the least common denominator. Or you can change them all to decimals. This one we're going to eliminate the fraction, and then the other inequality will work with decimals. So 4, 3, and 6 all have a common multiple of 12. So I'm going to multiply everything by 12 over 1. So 12 times 3/4 will give me 9. 12 times negative 2/3 will give me negative 8. And 12 times negative 5/6 will give me negative 10. So I have, is 9 greater than or equal to negative 18? That's a true statement. So I know that the ordered pair works in the first inequality. Now, in order for it to be a solution, it has to work in the second inequality as well. So I'm taking the second inequality, y greater than 3/5 x, and I'm substituting in the same numbers for x and y. So y will be 3/4 again, and I will be substituting negative 2/3 in for x. Now, you can change everything to decimals. I'm going to multiply 3/5 and negative 2/3 before I change to decimals. So I'll have 3/4 is greater than negative 6/15. Changing them to decimals will give me 0.75 for 3/4. Is that greater than negative 0.4? And it is. That's a true statement. So that means that negative 2/3 and 3/4 is a solution. All right, moving on to where we're actually going to graph a system of inequalities on our own. We have y greater than or equal to x plus 2, y greater than or equal to x minus 2. So we need to graph these, and then we'll talk about what area of the graph will be shaded. So I'm going to take the first inequality, and we have done some graphing with this in the past. Y equal to, y greater than or equal to x plus 2. When I go to graph it, remember I can change the greater than or equal to an equal sign in order to graph it. So I can graph it in different ways. I can make a table, I can do x and y intercepts. since this is in slope-intercept form, that's the way I'm going to graph it. The slope is 1 over 1 because there's a 1 here. So the slope is 1, and the y-intercept is 2. So it'll be 0. Oops, that's a little hard to see. 0, 2 for the y-intercept. So I'm going to put this on my graph. I'm going to start with the point 0, 2. And remember, for slope, I'm going up 1 and over 1, up 1 and over 1, and if I want to get more points, down 1 and over 1, down 1 and over 1. And now I'll give it my graph. And I need to check, is it going to be a solid line or a dashed line? Since it's greater than or equal to, it's going to be a solid line. Use blue here. So we have our line. Now at this point, I would check to see which side of the line you're shading. So I would pick your test point. And we talked about using 0, 0. That is the easier point to use if the line is not going through 0, 0. So I would use 0, 0 as my test point. I'm going to change this to a white box so we can see better. So my test point will be 0, 0. And I'm substituting those 0, 0 into my first equation for x and for y. So this again is my inequality. Substituting 0, 0 in will give me 0 greater than or equal to 0 plus 2. I want to know if this is a true statement. Is 0 greater than or equal to 2? And that is not a true statement. So that means that I would be shading the area above the line, because 0, 0 lies below, and this is not a true statement, so I'm shading this area above the line. Now I don't want to actually do that shading just yet, because this is a system of inequalities, so I have to see where the two systems overlap each other as far as the shading goes, because that will be my solution. Where they overlap will be my solution for shading. So what I do is I put little arrows to indicate that this is the side of the line that gets shaded for this line. So I put the little arrows so I know which side I'm shading. And we also can mark what equation this is up here in the corner. And now I'm going to erase this so I have room to do the next one, y greater than or equal to x minus 2. So if you need to write anything down, you'll need to pause it. So now I'm looking at y greater than or equal to x minus 2, which again I can change to y equal to x minus 2 in order to graph it. So my slope here is 1 over 1, this 1, and my y-intercept is negative 2. And I can write that as the ordered pair 0, negative 2. So I'm going to graph 0, negative 2 on my number line, or on my coordinate plane. And then I'm going to go up 1 and over 1, up 1 and over 1, and you can see what this graph looks like. So again, check to see if it's solid or dashed. It's going to be a solid line because of the greater than or equal to. And it looks like this. These are actually parallel lines because they have the same slope. Now I need to see which side of this line I need to shade, or this inequality. So my test point again is going to be 0, 0. So I'm taking y greater than or equal to x minus 2, and I'm substituting the zeros in. So is 0 greater than or equal to negative 2? It is, so I'm shading the area above this line. So to show that, I'm going to put my little arrows that I am shading above this line. So where would the two be overlapping? Well, remember, if I'm shading above this line, it's as if this line isn't here. So it doesn't create a barrier. I would be shading this whole portion of the coordinate plane. And for this line, I'm shading this portion of the coordinate plane. So the place where the two overlap each other would be right here in the upper corner. So let's shade that in. Actually, let's go over it one more time here. This line, the purple line, the y greater than or equal to x minus 2, I'm shading everything above this line. So I'm actually going over the blue line, shading everything above. For the blue line, y greater than or equal to x plus 2, I'm shading what's above this blue line. So the place where the two overlap each other would be this corner right here. So we're going to shade that in. And this would be my solution for this problem. So basically what it's saying is that if I take any ordered pair in this region of the coordinate plane, I can substitute it into both equations for x and y, and I get true statements. So for example, if I took this point, -3, 0, and I substituted it into the first one, I would get a true statement. And if I substitute it into the second one, I would get a true statement. All right, moving on. We're going to do another one here. Y greater than or equal to 3 and y less than -4. So, y greater than or equal to 3, I need to graph on my coordinate plane. So I'm graphing the equation y equal to 3. And remember, that's a horizontal line through 3 on the y-axis. So I'm drawing a horizontal line through that point. And it's greater than or equal to, so it's going to be a solid line rather than a dashed. So now what I need to do is decide which side of this line gets shaded. So I can pick a test point. I can pick 0, 0 because the line is not going through 0, 0. But I only have to worry about substituting the y value in because I don't have the x variable in this equation. So I will have is 0 greater than or equal to 3. 0 is not greater than or equal to 3, so I would be shading this side of the line, above the line. Then I'm going to erase this, so you'll need to pause if you need to copy any of this down. Y less than -4. When I graph it, it'll be y equal to -4. And y equal to -4 would be a horizontal line going through -4 on the y-axis. Now this is less than, so it's going to be a dashed line going through that point. So I need to pick a test point again. I can use 0, 0. Gotta love 0, 0. I'm using just the y value, so for y less than -4, I'm substituting the 0 in. Is 0 less than -4? No. So I'm shading below the line. So you can see that we have no overlapping going on for this system of inequalities. So we say that we have no solution. Or the solution, you may see it written as the empty set. And last but not least, I threw this one in here because on your quizzes, you usually have to identify the graph that corresponds with the system of equations, which I know can be a little bit tricky. So we're going to take a look at this one. And before we even get started, we want to determine, if you look, all of these look the same except for the shading. So I want to determine which inequality goes with which line. So for y greater than or equal to x plus 1, Is that the blue line or the red line? So actually I can pretty quickly tell by the fact that the slope of this line, y equal to x plus 1, is a positive slope. The slope for this one, -3/2, is a negative slope. So if you remember, we talked very briefly about if a graph shoots up to the right, it has a positive slope. If it shoots up to the left, it has a negative slope. So that right away tells me that the blue line is y greater than or equal to x plus 1, and the red is the other inequality. Now, if you don't have that case, I'm going to write here that they're blue ones. So this is the blue line, and this is the red line. Now, if you end up with a question where they are both positive slopes or both negative slopes, what you can do is look at the y-intercepts for the equations, which in this case, these both have the same y-intercept of 1 because they're both crossing the y-axis at 1. But then what you would need to do is look at the slope. So you could count units in order to figure that out. So if we look at the blue line starting at the y-intercept, to get to another point on it, we go up 1 and over 1. So you could see that the slope of this blue line is 1, and that corresponds with this equation, y equal to x plus 1. So that's another way to identify. And the reason that we need to know which equation goes with which line is because of the shading. So we're going to have to determine which is correct for the shading, and we need to know which line goes with which inequality. So what you can do then is determine test points and check where the shading should be for these lines. So if we take y greater than or equal to x plus 1, and we use a test point of 0, 0. Substituting 0, 0 in, we'll get 0 greater than or equal to 0 plus 1. So is 0 greater than or equal to 1? That's a no. So for the blue line, we should be shading above the blue line. So if you look, there's no shading above the blue line for A. So that's not going to be a correct answer. There's no shading above the blue line here for C, so we know we can eliminate that answer. There is shading above the blue line here for B and for D. So one of these is correct. So we can tell rather quickly too, because this is a dashed line, and we know that our red line is not going to be dashed, it's going to be solid. So we know that D is going to be our correct answer. But let's also do the test point for the red line, just so you can see that that is in fact the shading that's correct. So if we take y greater than or equal to -3/2 x plus 1, and we substitute in our test point, so we'll have 0 greater than or equal to -3/2 times 0 plus 1. And we're asking the question, is 0 greater than or equal to 1? That's a no also. So we would be shading this portion of this graph. And we also said we would be shading above the blue line. So you can see where the two overlap each other is right here. So again, it's D and not B because B has the red line as being dashed, and we know it has to be a solid line because of the equal to underneath the greater than sign. And that ends this session on systems of linear inequalities.